We are still working with the metric system, and you should be on page 159. 159, we're on lesson 4. Now, we know in the metric system that everything is based on multiples of 10 or powers of 10. So, just for a warm-up, let's decide if each statement is true or false. All right, it says 5,423 times 10 is 50,423. Well, let's remember our rules for multiplying by multiples of 10. We know our number's going to be getting bigger, so we know we would be moving the decimal place to the right. And right now our decimal place is right here. So if it moves by 1 power of 10, because that's what we're multiplying by, then it should just move 1 time. So we would have 1 empty drop loop. So our new answer would be 54,230, not 50,423. On theirs, all they did, they just multiplied the thousands place by the multiple of 10. But you have to multiply everything times a multiple of 10, so that's why everything moves up 1 multiple of 10. The 4 was a 400, so it moved up, and now it's 4,000. The 2 was a 20, so it moved up, and now it's 200. The 3 was a 1, it moved up, so now it's a 30. And then we didn't have anything here, so that's where our 0 comes from. We went up by 1 multiple of 10 on everything. Okay, well, we know that the opposite of multiplying by a power of 10 is dividing by a power of 10. So if we move our decimal this way, because we know our number's getting bigger, then it makes sense that we would move our decimal to the left because our number's going to be getting smaller by 1 multiple of 10. And right now, the decimal is here at the end. If we move 1 time, then it would be between the 2 and the 3. And that's what they have. So yes, this statement is true. Okay? And that's because everything moved down by 1 multiple of 10. The 3 was in the 1's place, so it moved down. Now it's a 10th. The 2 was in the 10's place, so it moved down 1, so now it's in the 1's place. The 400 moved down once, so now it's in the 10's place as a 40. And the 5 was 1,000, and it had to move down 1, so now it's in the hundreds, the 500's place. Okay, and then on the next one. This time they're moving by 2 multiples of 10, but we follow the same same thinking. If it moves 1 time for 1 power of 10, then it would move 2 times because everything's being bumped down by 2 multiples of 10. So 1, 2. And yes, this statement is also true. Okay, on the next, we are Andre's steps. It says each of Andre's steps is 50 centimeters. And they want us to fill out the table. Okay, well, we know, let's think, we know that King Henry died unusually drinking chocolate milk. So, first of all, we need to think. Each of Andre's steps is 50 centimeters. So, 1 step would be 50. They just told us 1 step is 50 centimeters. Now let's use our King Henry. Let me move that just a little bit. All right. The centimeters, here's centimeters, and meters, we know that's our basic unit because this doesn't mean meters. This means milli for 1,000. Okay, so we're at centimeters, and we need to go to change it to meters. So that would be moving the decimal or the place value 1, 2 multiples of 10. So right now, our decimal place is right here. And if we moved it 1, 2 places, then we would have 0.50. And that makes sense. If it was 50, and we know that there are 100 centimeters in a meter, it makes sense that now it would be hundredths instead of 50. Okay, and if you put 5/10, that would be the same thing, wouldn't it? 50 hundredths is equal to 5/10. All right, the next one. Well, this is 10 times what that is, so this should also be 10 times. So 50 times 10, that's one more power of 10, or one more multiple of 10, so that would mean one more 0 to represent a multiple of 10. So now we have 500, and that's centimeters. We're going to meters, so that would be 1, 2. Right now the decimal is here, so that would be 1, 2. So now we have 5. That makes sense. There's 100 of these in every one of these, so 500 of these would make 5 of these. 100 is 10 times more than 10. So the centimeters should be 10 times more. Anytime it's 10 times more, that's one more multiple of 10. So you would show one more place value of 10. And then we're at centimeters, we're going to meters, that's 1, 2. So that would be 1, 2. So this would be 50. The last one, again, 1,000 is 10 times greater than 100, so this should be 10 times greater. Anytime something is 10 times greater, a multiple of 10, we add one more multiple of 10. Okay, so now we're at 50,000. And let's think about that for a minute. If it takes 100 of these to make these, then I would be dividing this by 100. So I would be moving that 2 times. So this would be 500. And it makes sense over here. This is 10 times greater than this, and this is 10 times greater than this. What patterns do we notice in the table? Everything is increasing by multiples of 10. Okay, Andre lives 1.25 kilometers from school. How many steps is that? Well, let's think about that for a minute. One step, remember up there in number 1, it told us that one step is equal to 50 centimeters. So let's think about that. So 2 steps be 50 plus 50, wouldn't it? Because one step is 50 centimeters, so 2 steps would be 100 centimeters. And let's think about that, 100 centimeters. We know that centi is 100. Well, we talked about, we learned that in class. So 100 centimeters is the equivalent of 1 meter. All right. And it says, let's see, it's 1.25 kilometers from school. We're working now in meters, so let's get that put into meters. 1.25 kilometers. And we need to be in meters, so that would be 1, 2, 3 moves. 1, 2, 3, 3 multiples of 10. So 1, 2, 3, and anywhere we have an empty loop, we put a 0. So in meters, if we're thinking in meters from school, it would be 1,250. Okay? Now, if we have that it's 1,250 meters, and that is 2 steps, because that's what we put ours in, 2 steps. So if we divide this by 2, what is that going to give us? Let's see. Would we divide that by 2? Would we multiply that by 2? Okay, let's see. This was kilometers from school altogether. Well, if we multiply, that's one step. So if we multiply that by 2, then he would be walking 2,500 steps. 2,500 steps. All right. One day, Andre made a total of 8,500 steps. How many kilometers did he walk? Okay, if he walked 8,500 steps in all, and let's see, if we divide that by 2, we get, let's see, that would be 4,250 meters. 4,250 meters. Let's see. But it didn't ask us in meters. It asked us in kilometers. So if it's 4,250 in meters, then how many kilometers would that be? Let's see. If we're sitting at meters, that's 1, 2, 3. So if my decimal place is right here, that would be 1, 2, 3. So it would be 4.250, which is the same thing as 4.25. So he walked 4.25 kilometers when he made 8,500 steps. Whoop, still got my marker in my hand, just a second. All right, who ran farther? Use the table to find the total distance Tyler ran during the week and show your reasoning. All right, well, if we add all of these up, let's see. He ran 8.5 on Monday, and then he ran, oops, got one little number ahead of myself, 6.25, and remember, we have to keep everything lined up when we're adding. Okay, so we've got that one and that one. And it helps a lot of people, instead of stacking them all and then trying to add up all your numbers, some people like just go 2 at a time. Just make sure you check off what you've added though. We can placeholder 0 here. So we have 0 plus 5 is 5. We know we got to bring that decimal straight down because we're adding. 5 plus 2 is 7, and 8 plus 6 is 14. So now I add my next number. My next number is 10.3. Make sure you keep those place values lined up, straight down. Placeholder 0. 5 plus 0 is 5. 7 plus 3 is 10. Carry your 1. 4 plus 0 is 4, plus the 1 we carried is 5. And 1 plus 1 is 2. So we've got those 3 taken care of. Now I'm going to take what I've got down here so I can keep going. Okay, and I'm going to add my next number. 5 and 75 hundredths. And we know we can bring that decimal straight on down. 5 plus 5 is 10. Carry your 1. 0 plus 7 is 7, plus the 1 you carried is 8. 5 plus 5 is 10. Carry your 1. 2 plus nothing, or 2 plus 0, if we placeholder, is still 2, plus the 1 we carried is 3. So now I've taken care of all 3 of those, and I have 1 left. 9 25 hundredths. Notice how I'm keeping all of my place values lined up. Drop my decimal down to the bottom. 0 plus 5 is 5. 8 plus 2 is 10. Carry your 1. 0 plus 9 is 9, plus the 1 you carried is 10. Carry your 1. 3 plus nothing, or 3 plus 0 if you placeholder 0, is still 3, plus the one you carried is 4. So in all, Tyler ran 40 5/100 kilometers. Okay, so that's what he ran all together. When we got everything added up, that's how many kilometers he ran all together. All right, now it says, use the table to determine Claire's, that Claire ran that week. Okay, we're going to use the same process. Claire ran 5,400 on Monday and 7,500 on Tuesday. 0 plus 0 is 0. 0 plus 0 is 0. 4 plus 5 is 9. And 5 plus 7 is 12. Then we add our next day. 8,250. Make sure you're keeping your place values in place. We're taking care of that one. So 0 plus 0 is 0. 0 plus 5 is 5. 9 plus 2 is 11. Carry your 1. 2 plus 8 is 10. Plus the one you carried is 11. Carry your 1. 1 plus nothing, or 1 plus 0 is 1. Plus the one you carried is 2. Now we have 21,150. And we're going to take care of this one. 6,750. Make sure you keep your place values in line. 0 plus 0 is 0. 5 plus 5 is 10. Carry the 1. 1 plus 7 is 8. Plus the one you carried is 9. 1 plus 6 is 7. And 2 plus nothing, or 2 plus 0 is 2. And then finally, our last day, Friday, 7,250. Keep your place values in line. 0 plus 0 is 0. 0 plus 5 is 5. 9 plus 2 is 11. Carry your 1. 7 plus 7 is 14. Plus the one you carried is 15. Carry your 1. 2 plus nothing, or 2 plus 0 is 2. Plus the one you carried is 3. All right. Now, so she ran 35,150 meters. All right, so we know what he ran and we know what she ran. All right, then it says, who ran farther, Claire or Tyler? Well, first we have to get them in the same units, don't we? Tyler figured his in kilometers and Claire figured hers in meters. So it doesn't matter which one we convert to the other, because it's still going to have the same value. It's just going to be in a different form. So let's change Tyler's to meters. So Tyler did his in kilometers, so he's at K, and he wants to get to meters. So that would be 1, 2, 3 multiples of 10. 3 multiples of 10. Right now our decimal place is here. So if I move it 1, 2, 3 multiples of 10, I would have one empty drop loop. So I would put a 0. So Tyler ran 40,050 meters. Okay? So now can we see who ran the farthest? Well, Tyler did, didn't he? Claire ran 35,150. Tyler ran 40,050. So Tyler ran more. Then they asked how much farther? Well, we would have to, if it says how much farther, we know we're subtracting. So let's take Claire's away from Tyler's. Zero minus 0 is 0. 5 minus 5 is 0. We can't take 1 from 0, so we'll have to borrow. And he said he would, but he didn't have quite enough, so he's going to have to borrow over. So we're going to borrow 1 multiple of 10 from him, and that will become a 3. We borrowed one multiple of 10, but he doesn't get to keep it all because he promised him some, so he'll be a 9, and then he'll be a 10. All right, so then 10 minus 1 is 9. 9 minus 5 is 4. And 3 minus 3 is 0. And we put in our comma. So the difference between Tyler and Claire was 4,900 meters. And now let's put it back in kilometers. So if we're here at meters and we want to go to kilometers, it would be 1, 2, 3 multiples of 10. It's here right now. So 1, 2, 3 multiples of 10. So to put it back in kilometers, it would be 4.9, and then 0, 0. It doesn't change the value. It would still be 4 and 9 tenths because 4 and 9 thousandths is equivalent to 4 and 9 tenths. Okay, now, everything we've done so far has been in metric length, so it's been in meters. Now we're going to switch to measuring liquids. But the good thing with the metric system, unlike our system, the customary system that we use in America, where everything is so different, 1 foot equals 3 feet equals 1 yard, and let's see, 8 ounces in a cup, and 2 pints in a quart. So ours is all crazy. But with the metric system, it doesn't matter if you're working in liquids or in measuring length or even weight in grams. It all still works through the same metric system of multiples or powers of 10. So this time, instead of our unit being meters, our unit's going to be liters. But nothing else changes. All right, so we already know if we're dividing by a multiple of 10, our number should be getting smaller. And the way to make a number smaller is to move every place value over by 1. So if we move this by 1, then this is equivalent to 140, which that makes sense. I'm taking away one multiple of 10. On the next one, we're taking away 2 multiples of 10. 1, 2. So we would have 14 instead of being 1,400. That makes sense. 1,400 divided by 100. Well, that leaves me 14. And then the last one. Oh, not the last one. Next to last one. 1,400 or 1,400 divided by 1,000. Well, now we're changing by 3 multiples of 10. So 1, 2, 3. So 1 and 4 tenths. And then 14,001 divided by 1,000. 1, 2, 3. 1.4. 1 and 401 thousandths. All right. In our table, it's wanting us to change liters to milliliters. Okay, meters to milliliters. And it doesn't work any differently than we did when we were working with meters. Now we're just using liters because it's liquid. So if we're wanting to go from liters, our base unit, to milliliters, that would be 1, 2, 3. And we have to remember from class that milli is 1,000th. So it would take 1,000 of these to make 1 liter. All right, so if we're going from liters to milliliters, we know this number is going to be a lot higher because it takes a lot more of these to make 1 of those. So if I have 5 and I need to get to milliliters, that's 1, 2, 3 moves or 3 multiples of 10. Right now the decimal's here. 1, 2, 3. We would have 3 empty drop loops. So this would be 5,000 milliliters. Well, that makes sense. We said milli was 1,000th. We said it would take 1,000 milliliters to get 1 liter. So it would take 5,000 milliliters to get 5 liters. Okay, on the next one, if we have 6.3 liters, it's still, we're going to milliliters, it's 3 multiples of 10, 1, 2, 3. So we would be shifting 1, 2, 3. So we would have 2 empty drop loops. So it would take 6,300 milliliters to make 6 3/10 liters. 9,500 liters. We're still moving 3 multiples of 10 because we're still going to milliliters. So 1, 2, 3, 1 empty drop loop, 950 milliliters. And then they give us this weird one. All right, this weird one is it 10 to the 2? What does that mean, 10 to the 2? Oh, yeah, that means 10, 2 multiples of 10. So 10 times 10, so I know that's 100, okay? So if that's 100 liters and I'm trying to get to milliliters, that's still a move of 3 multiples of 10. So if I did 1, 2, 3, I would have 3 empty drop loops. So that would be 100,000. And that makes total sense. If this is 100 and it takes 1,000 milliliters to be 1 liter, it would take 100,000 milliliters to be 100. All right, now it's asking us to go in the reverse, change from milliliters to liters. So all we're doing is we're going to be taking away multiples of 10 instead of adding multiples of 10. So if we're at milliliters, and we need to be at liters, our base unit, that would be 1, 2, 3 multiples of 10 to the left. So 1, 2, 3. So 800 liters. That makes sense. 800,000 divided by 1,000 would be 800. All right, and then they give us this crazy number again, but remember, it just means 10 multiplied by 10 6 times. So we could just write down our base 1, and then the exponent tells us how many multiples of 10, and it's 6. So 1, 2, 3, 4, 5, 6. Okay, so 1 million milliliters is equal to, if we had to move 3 times, that would be 1, 2, 3. So that would be 1,000. Now, if you want to write it in the same as what they have it in, well, let's look at this. We have 3 multiples of 10. So that would be 10 to the 3rd power. And then the final one, 65. If we had to move 3 multiples of 10, here's the decimal, 1, 2, 3. We have 1 empty drop loop. So 65 milliliters would be 65 thousandths liters. And that makes sense because it takes 1,000 of these to make 1 of these. Okay, decide if the 2 measures are equal. If not, choose which one is greater. Okay, well, the first thing, if we're going to see if they're equal, we've got to get them in the same units. So let's change everything. So they had milliliters first, so we'll just change everything to milliliters. If we change this to milliliters, we're at liters now. That's our base unit in the middle. To get it to milliliters, we would have to move 1, 2, 3 multiples of 10 to the right. So 1, 2, 3, I would have 1 empty drop loop. So this is 150 milliliters. Well, this is still 15. We didn't change that one, did we? So 15 is definitely less than 150. So in the original, the 1,500 liters would be the bigger. All right, in the next one, in order to see which one's largest, you have to have them in the same conversion. We have to have them in the same. This one's in milliliters, this one's in liters. Again, we'll just switch to milliliters since that's what they have first. So that's 2,500 milliliters. All right, if we're changing 2.5 liters, again, liters is our base unit in the center, and it would, if we're going to milliliters, that's 1,000th. So it would be 1, 2, 3, 1, 2, 3. This time we have 2 empty loops. So it would be 2,500. So let's see. Well, that's equal, isn't it? 2,500 and 2,500, so these are equal. Neither one is larger. And then our last one, well, not our last one, I think it's the last one. All right, this is in milliliters and this is in liters. We'll just stick with what the first one is, milliliters. Now, this 1/4 of a liter, where have I heard 1/4? If we're thinking of anything in fourths, let's think of it as money. So if I had $1, I would have 4 quarters. So 1/4, 1/4 is 0.25. So 0.25 liters. And if we're going to milliliters, that would be 3 multiples of 10. So 1, 2, 3. This would be an empty drop loop. So this would be 250 milliliters. Well, 200 milliliters is less than 250 milliliters, so 1/4 liter is bigger. Okay, 1 milliliter versus 1,000th liters. So we have our 1 milliliter. If we convert this, well, first we have to get it in a decimal so that we can move our decimal, don't we? So 1,000th. Thousandths is 1, 2, 3 place values, so that's the same as 1,000th. And if we're going from liters, our base unit, to milli, that's 1,000th. That's 1, 2, 3 multiples of 10. 1, 2, 3. So 1 milliliter is equal to 1,000 liters. Look, they're the same. Okay? So even though this may, if you just glance at it, oh, so you're thinking, oh, that's way less because it's 1,000th. But liters versus milliliters, it's actually the same. All right, 15,600 milliliters. Okay, and this one's in liters. So if we want to get them the same, it's 3 multiples of 10, 3 place values. So 1, 2, 3. There's the 5's in that loop, so this would be 1, 0, 2 zeros. Well, 15,600 is just a little bit bigger than 15,500. So the 15,600 milliliters is more. All right, next page. Rehydrating Dancers. Okay, it says there are 25 dancers in the performance group. During practice, each dancer drinks 1.5 bottles of water. Each bottle, problem number 1, each bottle holds 500 milliliters of water. How many liters of water do the dancers drink? Wow, we're going to do a lot in this one, aren't we? Okay, so let's think for a minute. Each bottle is 500 milliliters. So one bottle's 500, but they drink 1.5 bottles. So I got the one covered. That's the one bottle, 500 milliliters. And then what's half of 500? Well, if you're not sure, 500 divide it by 2. 2 goes into 5 2 times. 2 times 2 is 4. Subtract. Bring down your 0. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and get 0. And then we have one more 0 to bring down. Remember, we can't stop until all of our numbers are covered. 2 goes into 0 0 times. 0 times 0. 0 times 2 is 0. And we end up with 0. So half of 500 is 250. Okay? So altogether, each dancer drinks 750 milliliters. Okay? They all drink. Each dancer drinks 750 milliliters. And then we have to think, well, how many dancers are there? There's 25 dancers, so 750 25 times. 5 times 0 is 0. 5 times 5 is 25. Carry the 2. 5 times 7 is 35. Plus the 2 we carried is 37. And now we're dealing with the second number. So we are in the second row. So we need to be under the second number when we start our actual math. So we want a placeholder 0. 2 times 0 is 0. 2 times 5 is 10. I've already used that one. Carry your 1. 7 times 2 is 14. Plus the 1 we carried is 15. And make sure you keep your place values. 0 plus 0 is 0. 0 plus 5 is 5. 7 plus 0 is 7. 3 plus 5 is 8. And nothing plus 1 is 1. So all together, they drink 18,750 milliliters. That's a lot of, sounds like a lot of water, doesn't it? All right, question number 2. Leaving that there because we're going to need it. Okay, question number 2. Each cooler holds 15 liters of water. And we can see that there. They've got the little thing for us. Each cooler holds 15 liters of water. How many coolers does the team need? Well, first of all, we found our answer in milliliters. So the first thing we're going to need to do is convert ours over to liters, because that's what they're measuring the jugs in. So to get from milliliters to liters, that's 1,000th down here. So that will be 1, 2, 3 moves. So 1, 2, 3 multiples of 10. Okay, so it would be equivalent to 18.75 liters. Okay, and let's see. Each cooler is 15, so we know we're going to need more than one cooler. So let's just go ahead, 2 coolers, 15. If we had 2 coolers, that would give us 30 liters. But we're not using that many, we're only using this many. So let's take away how many we're using. We're using 18.75 liters. And we can put a decimal there, still equal to 30, doesn't change the value. We can placeholder zeros here. We're subtracting, so we drop our decimal straight down. All right, well, we can't take 5 from 0, so he's gonna have to borrow. He doesn't quite have it, so he's gonna have to borrow. He doesn't quite have it, so he's gonna have to borrow. So we're doing a lot of borrowing here. We borrowed that multiple of 10, so he'll become 2. He borrowed a multiple of 10, but he'd already gave some away, so he's a 9. Same for him. He had already given him some, so he's a 9. And then he will be 10. So 10 minus 5 is 5. 9 minus 7 is 2. 9 minus 8 is 1. And 2 minus 1 is 1. So we have, it's asked how much would be left over after practice. 11.25. All right, number 3. dancers can make a sports drink by mixing 30 milliliters of drink mix with each 500 milliliters of water. How many liters of drink mix does the team need for their practice? Well, let's see. Takes 30 milliliters for 500 milliliter bottle. And let's see, that is one bottle. They drink one, we gotta remember back to problem number 1. They drink 1.5 bottles. Okay, so 1.5 bottles would have to be equal to your milliliters of drink mix. So it would take, we're thinking about 1.5. It would take 30 and then half of 30. What's half of 30? Well, half of 30 is 15, isn't it? So they would need 45 milliliters of drink mix. All right, so if each one of them needs 45 milliliters of drink mix, then we have to think, well, how many people are there? Well, there's 25. So they would need 45 milliliters 25 times. 5 times 5 is 25. Carry your 2. 5 times 4 is 20, plus the 2 that we carried is 22. We're working with the second number in the second row, so we need to be under the second number when we start our actual math. So we'll placeholder 0 here. Already used that. 2 times 5 is 10, plus the 1. 2 times 4 is 8, plus the 1 we carried is 9. And then we add. 5 plus 0 is 5. 2 plus 0 is 2. 2 plus 9 is 11. So, now this is in milliliters. They asked how many liters of drink mix. So this is in milliliters. Let's get that converted. Excuse me, there you go. Let me transfer that up here. Okay, if we said it's 1,125 milliliters, but they asked the question in liters, we would need to convert this to liters. So if we're at milliliters and we need to be here, that's 1, 2, 3 multiples of 10. So 1, 2, 3. So they would need 1 and 125,000 liters to make the drinks for practice. All right, that's it for today, guys. Hope you have a great weekend. Bye-bye.